Now, protocols are separated according to their functions based upon an industry standard reference model called the Open Systems Interconnect, or OSI model. This model was originally published in 1983 by ISO, the International Organization for Standardization, as a document called ISO 7498. Now you'll see here we've got 7 layers, and it's a hierarchical model. So it's top to bottom or bottom to top, depending on which way you want to go, and the order definitely matters. But the idea here is to make it, at least for our purposes, much easier to understand network communication. Again, there's a top layer and a bottom layer. So in this case, the application layer at the top represents the actual programs used to access network resources. And the bottom layer is the physical layer through which the actual network data travels. So either wireless or wired. So you have increasing abstraction from the source data as you go up this hierarchical model. The idea is that each layer has a protocol that performs a function, and the protocols at each layer work together to ensure data is properly handled by the protocols operating at the layers above and below it. So again, we have 7 layers here, and it's really important to remember these because we're going to be referencing these throughout the course of our training exercise here and throughout all the other different lectures. So we're going to talk about different specific protocols, and I'll mention those. I'll mention, TCP is a transport protocol, whereas IP is a network protocol, whereas HTTP is an application protocol. And those things are going to mean different things, and I want you to be able to conceptualize those in the context of what's going on in relation to this model. The OSI model is not the only model for describing this type of thing. There's the what's called the DoD or TCP/IP model, which is another way to do it. But I really like the OSI model. I just think it works better for describing this type of information, this type of interplay between the different pieces of data and protocols we're going to be dealing with. So it's really important to remember these. I want to give you a little mnemonic device that will help you. It's one I've used for a while, and it's very simple. Please do not throw sausage pizza away. Sausage pizza is delicious, so it's not hard for me to remember. But the idea is this is giving you the order of the layers from bottom to top. So PDNTSPA is physical, data link, network, transport, session, presentation, and application. So that's what you can remember. Please do not throw sausage pizza away. Now, let's talk a little bit more about some of these layers on this model. But instead of just describing them independently, I actually want to talk about them through the lens of a few example protocols for each one. The idea being, if you kind of understand the protocols a little bit already, then you can understand what each layer is doing in terms of function. So let's go through each layer of the OSI model and talk about common protocols we would find there and how that relates to the functions you commonly find at each layer. And we'll start with the top and work our way down. So we'll start with the application layer. The important thing to understand about the application layer is it provides a means to actually access network resources and is really the only layer typically interacted with directly by the human user initiating some type of communication. And we do that with protocols like HTTP, SMTP, DNS, and FTP. HTTP should be a pretty common sounding protocol to you. That's the Hypertext Transfer Protocol, and it's what allows us to communicate with web servers. So by itself, HTTP in conjunction with the other lower level protocols that are used with it is what allows you to request a web page and retrieve that data from the web server. Now, again, to do that, it has to rely on all the things below it as well. But at an application layer, your web browser is relying on HTTP to communicate with a web server, both of those devices speaking this HTTP protocol. The same thing this can be said for SMTP, Secure Mail Transfer Protocol, which is used by your email client and your email server to send email. So that's a protocol you would rely on for that. So we'll spend a lot of time talking about application layer protocols because they're very important for a lot of things, both troubleshooting and security and all sorts of different things there. So application layer protocols are something we'll spend a lot of time in. And to some degree, those may be the protocols you're already the most familiar with. Moving down to layer 6, we have the presentation layer. And the presentation layer is all about transforming data into a format that's readable by the application layer. Remember that each layer is responsible for dealing with the layer above and below it. So you see things like ASCII or MPEG or JPEG. You think of these as file formats or data formats. It's important for an application layer protocol to receive data in a format it can understand, and the presentation layer is what really allows that to happen. Of course, this is a little less of a network activity, right? A JPEG isn't a network protocol, right? It's a file format. So we're not going to spend a lot of time talking about presentation, that layer, so to speak, as much as we would something like the application layer. Next is the session layer, which is one of the more ambiguous layers because it handles a couple functions that can also be handled elsewhere. It's responsible for handling the dialogue between hosts. So this includes things like ensuring a connection stays alive, authentication, authorization, some of those things. Granted, you'll notice some of the protocols I've listed here, NetBIOS, SAP SDP, they're not things you see as much of. Certainly NetBIOS you will on Windows environments, but you don't see a lot of session protocols because a lot of these functions are also handled above at the application layer. So we're not really going to spend a lot of time talking about session layer protocols in this course just because it's not something you'll encounter nearly as often as some of the other things, but it is important to mention kind of the function of the session layer there. Next up, we have the transport layer, which is layer 4 in this stack. And transport layer is really responsible for reliable data transmission. Network communication wouldn't be too effective if there were no reliability mechanisms built in. Of course, we all know networks are subject to all kinds of factors that can cause little hiccups or slowdowns, and the transport layer really contains protocols that are responsible for helping ensure that the state of a connection is maintained and that the connection can survive these little hiccups or slowdowns, and also account for network congestion. Certainly congestion in a traditional sense, more of a concern of the past when you're talking about hubs and things, which we'll talk about a little later. But nonetheless, network congestion is still a problem and something we have to consider, and the transport layer and protocols like TCP are used for that. Next up, we have the network layer, and the network layer is really responsible for addressing things, providing network addresses that allow for communication outside of a specific network. So if I have a computer on my network and I want to talk to another computer on Joe's network, and they're two separate networks, I require a network address and routing protocols that will route my request to his network and eventually to his system. So the network layer is what allows for that communication to happen outside your network. And in most cases, we're all utilizing some services here because we're all communicating, for the most part, outside of our own network. That may not be the case in all networks, super secure, very small networks, things of that nature. But for the most part, we're all communicating with things out on the internet, which constitutes lots of other networks. So we have protocols like IPv4, IPv6, and the much older, less used these days, IPX as an example here for network protocols. Next up is layer 2, which is the data link layer. And the data link layer is responsible for providing physical addressing and a means of transferring data between hosts on the same network. So as the network layer is responsible for communication across networks, the data link layer is responsible for communications within the same network. So you're talking about things like Ethernet here, where we're talking about MAC addressing and being able to communicate with a device on the same network using only the physical MAC address. Also, a couple other standards mentioned there, the old school token ring as well as FDDI are mentioned as well. But Ethernet, for the most part, is the protocol we're talking about when we deal with data link. Although there's also VPN type protocols and tunneling protocols that also play into data link. The data link layer that can be considered. Last, but certainly not least, is the physical layer. And whereas an application layer is the closest you'll get with interacting with the actual software that communicates network data across the wire, the physical layer represents the wire itself. So it's the actual communication specs that are used to define how data is transmitted either across a physical wire or across a wireless network. So the actual physical medium used to transmit data. At this point, we're talking more about bits and electrical signals more than anything. So that's a little bit beyond our scope. So we're not going to spend a lot of time at the physical layer, but it's important to know that that's kind of what we're working down towards, is from this highest level of abstraction at the application layer all the way down to the lowest level of abstraction, which is the physical layer, where you're actually dealing with ones and zeros, the presence or absence of electrical signal, and the fundamental building blocks of what allow data to be represented by electric signals. So this is all 7 of the layers here, again, top to bottom. It's important to understand that some services have some overlap. So again, I mentioned that a lot of things that might be more traditionally associated with the session layer are actually handled by the application layer. And we also have the concept of some layers often aren't as involved as they might be in other cases. So for instance, the transport layer is responsible for reliable communication. That doesn't always happen there. If you're using TCP, then there's a lot of reliability measures built into TCP. But if you're using UDP, there are almost none. When you're using UDP, you're basically saying, hey, the transport layer is not going to handle this. It's probably going to be handled at the application layer or not handled at all, right? So we have the ability to kind of pass the buck on, so to speak, in that regard. And hopefully that'll make a little bit more sense when we talk about TCP and UDP a little bit later. Again, this is just, when we talk about the OSI model, this is just a reference model. It's a way to think and process these things and reference them intelligently in discourse like the one we're having here. So it's important, but it's not religion. It's not science. It's just kind of a way to reference these things, right? So your mileage may vary a little bit, and you may find some layers performing functions that might be more traditionally associated with the other layers. Now, for our purposes here, we're really focused on only a few of these layers. We're really going to be talking mostly about layers 2, 3, and 4, so data link, network, and transport, as well as layer 7, so application. We're really not going to delve too much into session and presentation protocols. They're a little beyond our scope. And we're not going to deal a lot with physical transmission media, other than to talk about some network devices and how we can capture packets using like inline packet capture and taps and things like that. So we'll talk a little bit about the physical, mostly from a software and analysis side. We'll be focused on data link, network, transport, and application. So how does OSI-based communication work? So how does network communication work based upon the OSI model? How do we frame it in the way that the OSI model allows us to do that? Now, the initial data transfer on a network begins at the application layer, and that's what we have on this diagram here. You see we have, starting at the top left, we have data moving down over to the other device and then back up. So data works its way down the 7 layers of the OSI model until it reaches the physical layer, at which point the physical layer of the transmitting system sends the data to the receiving system. The receiving system picks up the data at its physical layer, and the data proceeds up the remaining layers of the receiving system to the application layer at the top. The idea here is that services provided by various protocols at any given layer of the OSI model are not redundant. So for example, if a protocol at one layer provides a particular service, then no other protocol at any other layer will provide that same service, right? It's ideally only happening at one place. Protocols at different levels may have features with similar goals, but they're going to function a little bit differently. It's also important to note that protocols at corresponding layers on the sending and receiving systems are complementary. For example, if a protocol on layer 7 of the sending computer is responsible for encrypting the data being transmitted, then the corresponding protocol on layer 7 of the receiving system is expected to be responsible for decrypting that data. So complementary layers. Now, this process of building these data transmission units is essentially the process of building packets. That's what we're doing. And it's done through a process of encapsulation, which is what we have happening on the left here when we build this packet. And then when the packet is received, we have the process of decapsulation, and that's occurring on the right side of the screen where data is being stripped away one layer at a time. So let's talk about an actual practical example of what encapsulation and decapsulation looks like and how we build a packet.